Hello friends, I am Utsav Kumar. Welcome back to my channel. Today we are going to discuss architecture of radio access network. So first of all, we will review the internal architecture of the next generation Node B. So in LTE, the eNode B was originally specified as a single network element for installation at the local site. In contrast, the GNB has a number of internal components which communicate across open interfaces that are defined by the specifications. So 3GPP investigated several possible functional splits as a part of its studies into 5G. The one selected is we are showing here in the figure. So the GNB central unit is intended for installation away from the cell site, for example, at a nearby hub. Each central unit controls one or more GNB distributed units which are intended for local installations. In turn, each distributed unit controls one or more cells using low-level functions such as digital signal processing, scheduling, and retransmission. The central and distributed units communicate over a new reference point, which is known as the F1 interface. If a mobile is in carrier aggregation, then it communicates with one distributed unit and one central unit alone. So this is a very important point to consider. In dual connectivity, a mobile has two distributed units which are controlled either by the same central unit or by different ones. The central unit has two components of its own, the GNB central unit user plane and control plane. So the GNB central unit control plane exchanges signaling messages with the mobile, the core network and other nodes, and processes those messages using high-level functions such as encryption and decryption. It also controls one or more GNB central unit user planes which have a similar role in respect of user plane traffic. The control and user plane communicate over another new reference point known as the E1 interface. Optionally, the tasks of radio transmission and reception can be implemented separately using an antenna panel that is known as the remote radio head, or normally we call it RRH. Now coming to the deployment options. So the network operator can use internal architecture of the GNB, which we discussed in the previous slide, in several different ways to help them gain the benefit of natural function virtualization and software defined networking. So this NFP and software defined networking we have discussed briefly in our previous video. So I will link the video description and you guys can follow that. Now coming back, let's take an example in the figure. So for example, a network that contains four types of site, local cell sites around let's say 1000 or to 10,000 in a medium-sized country such as United Kingdom, together with local access hubs, regional access hubs and site containing core network equipment. So in a traditional LTE deployment, the base station is installed at the local site while the access hub contain only low-level network elements such as routers and security gateway. Now in the figure which we have shown, the network operator might centralize the central unit's user plane at the local access hubs while centralizing their control planes further at the regional hubs. If those network functions also virtualized, then the operator can gain the benefit of RAN centralization and virtualization. In addition, one task of the central unit is to support dual connectivity by forwarding traffic and signaling message to the appropriate distributed units. By centralizing the central units, the network architecture for dual connectivity is simplified. Optionally, the operator can also cache data at the local hub and can install local user plane functions there in support of multi-access edge computing. That can significantly reduce the user plane latency. Now coming to data transport. This is a very important topic to review. So we will start with the definition. So a data radio bearer, which is DRB, is a data pipe in the NG-RAN which transports packets over a defined route using a defined configuration of underlying air interface protocols. A DRB usually carries packets that belongs to a single quality of service QoS flow, but it can also carry packets that belong to multiple QoS flows in the same protocol data unit PDO session. So from the viewpoint of core network, there are two types of data radio bearer: an MN termination bearer in which the core network exchanges packets with the master node, and an SN terminated bearer in which it exchanges packets directly with the secondary. Now coming to the viewpoint of mobile, there are three types of DRB. An MCG bearer in which the mobile exchanges packets with the master node, an SCG bearer in which it exchanges packet with the secondary, and a split bearer in which individually packets can be routed through either node or duplicated through both to improve the reliability. So the distinction between DRBs and QoS flow is new to 5G core network and the NG-RAN. It was introduced to uncouple the treatment of quality of service in the core and radio access networks and to support the use of non-3GPP access network, for example Wi-Fi, in which the support of QoS can be very different. There is less of a distinction when using the EPC and EUT RAN, but the available routes to the RAN are the same. Now coming to network areas and identities. So the very first one is tracking areas. So the NG-RAN is organized into tracking areas, and its heart, a tracking area, is a small geographical region containing perhaps 100 nodes, although the exact number might vary considerably. Each tracking area serves one or more type of network slice, so an operator can restrict a network slice to certain tracking areas only. The NG-RAN tracking areas do not overlap. A cell lies in just one tracking area, but a node can lie in multiple tracking areas by virtue of controlling multiple cells. Each tracking area is identified by a 24-bit tracking area code tag, which is unique within the public land mobile network. Adding the public land mobile network identity gives the tracking area identity, which we normally call it TAI tag, which is globally unique. Now coming to RAN areas. So in the NG-RAN, each tracking area can be divided into one or more radio access network areas. As before, a cell lies in just one RAN area, but a node can lie in more than one. A RAN area is identified by a 8-bit RAN area code, which is unique within the tracking area. So the RAN areas are the basis of mobile specific RAN based notification areas. These are similar to tracking area list but are defined in a more flexible way. Each one spans either a list of RAN areas or a list of individual cells within the single tracking area. So the RAN based notification areas are used by mobiles in the state of RRC inactive, which we will discuss again in next video. So this is a very important point. Now coming to cell identities. Every NR cell has a 36-bit identity that is unique within the PLMN, which is known as the new radio cell identity, in short NCI. By combining that with the PLMN ID, we arrive at the new radio cell global identity, that is NCGI, which is again globally unique. The NCI is rather long, so a cell is more often identified using its physical cell identity, which ranges from 0 to 1007. Nearby cells or the same frequency must have different physical cell identities to ensure that the mobile can distinguish them. The physical cell identities are organized into 336 cell identity groups, each of which contains 3 identities. Optionally, network operators can configure a 3-sector GNB so that its sector have different physical cell identities within the same group, but that is again not essential. So these topics now mainly covers the architecture of the RAN new radio for the 5G. Now in the upcoming video, I will normally cover the protocol stack of 5G network. And then again, we will one by one, we will define the physical layer, the MAC layer, and so on till the L3 layer. Thank you.